Hey everyone, how are you all doing? This is Ayush here. You can also call me Shichi, and today I'll be starting the C programming language series. In this series, I'll go through all the fundamentals of the C language, and at the end, we will be building out our own custom text editor. Now, starting out, let's take a quick look at C's history, its coming of age as a standardized language, and its influence on other recent languages. C is a byproduct of the Unix operating system project, which was developed at Bell Labs by Ken Thompson, Dennis Ritchie, and others. Like other operating systems of the time, Unix was written in assembly language. Now, programs written in assembly are usually painful to debug and extremely hard to enhance, and Unix was no exception. Thompson decided a high-level language would be needed for Unix, so he designed a new small language called B. Dennis Ritchie soon joined the Unix project and began programming in B. Now, in 1970, Bell Labs acquired a PDP-11, a mini-computer system for the Unix project. Once B was up and running on it, Thompson wrote a chunk of Unix in B. By 1971, it was apparent B was not well suited to the PDP-11 system, so Ritchie began to develop an extended version of B. He called this new language NB, short for New B at first. Then as it began diverging from B, he changed the name to C. The language was stable enough by 1973 so that Unix could be rewritten in C. This switch to C provided a big benefit, portability. By writing compilers for different machines, compilers which are programs that convert code instructions to machine code so that the code can be executed on the given platform. The team could now write C code and run it on any machine. From then on, C continued to evolve during the 1970s, and the first book on C came out in 1978. Named The C Programming Language, written by Brian Kernighan and Dennis Ritchie. This book quickly became the Bible of C programmers. In absence of an official standard for C, this book known as KNR became the de facto standard. The language slowly kept on becoming more and more popular from then on, and then in 1988, the official standard was developed by the American National Standard Institute, shortened to ANSI, and this standard came to be known formally as ANSI C in 1990. This version is usually referred to as C89 or C90. The term C89 is also ambiguous with the term ANSI C. Let's talk about C-based languages. C has had a huge influence on modern-day programming languages, many of which borrow heavily from it. C++ includes all the features of C, but adds classes and other features to support object-oriented programming. Java is based on C++ and therefore inherits many C features. C# is a more recent language derived from C++ and Java. Now that you have learned the history of C, you will ask this important question: is it worth it to learn C? The answer is a simple yes. While learning C, you will gain insights into how C++, Java, and other high-level languages work, and it will make it easier for you to learn them, making you language agnostic. Also, the world runs on C. The Linux operating system made by Linus Torvalds is written in C. Embedded systems which are used in airlines and trains and throughout the world are also coded in C. Also, you'll be able to use everything taught in these lectures if you later decide to learn C++ or other languages. Let's talk about strengths and weaknesses of C. C is a low-level language. To serve as a suitable language for systems programming, C provides access to machine-level concepts, bytes and addresses, for example, that other programming languages try to hide. C also provides operations that correspond closely to a computer's built-in instructions, so that programs can be fast. Since application programs rely on it for input-output, storage management, and numerous other services, an operating system cannot afford to be slow. C is a small language. C provides a more limited set of features than many other languages. The reference manual in the second edition of KNR covers the entire language in 49 pages alone. To keep the number of features small, C relies heavily on a library of standard functions. C is also a permissive language. C assumes that you know what you're doing, so it allows you a wider degree of freedom than many other languages. Moreover, C doesn't mandate the detailed error checking found in other languages. C's strengths also include efficiency, portability, and power and flexibility. The weaknesses of C are that C programs can be error-prone due to its flexibility. C programs can also be sometimes difficult to understand and modify. But the strengths outweigh the weaknesses enough that C is one of the most widely used languages in the world. Now we will write our first code in C, the hello world code which outputs hello world out to the terminal. To run C in your computers, for Windows users, you'll have to install MinGW, the compiler, and a text editor. I'm using Visual Studio Code here. For Linux users, GCC is already installed on Linux platforms, and you can use any code editor of your choice. For this, for our first program, make a new file, name it hello.c, and write this code. Includes stdio.h, int main void, printf hello world. Printf is a function which prints out to the console. Return 0. The line #include stdio.h is necessary to include information about C's standard input-output library. The program's executable code goes inside main, the main function, which represents the main program. The only line inside main is a command to display the desired message. Printf is a function from the standard input-output library that can produce nicely formatted output. The \n code tells printf to advance to the next line after printing the message. The line return 0 indicates that the program returns the value 0 to the operating system when it terminates. Despite its ease of writing, getting hello.c to run is more involved than you might expect. The name of the file doesn't matter, but the .c extension is often required by compilers. Next, we've got to convert the program to a form that the machine can execute. For a C program, that usually involves 3 steps. The first step, preprocessing. The program is first given to a preprocessor which obeys commands that begin with hashtag, known as directives. A preprocessor is a bit like an editor. It can add things to the program and make modifications. Compiling. The modified program now goes to a compiler, which translates it into machine instructions, machine code. The program isn't quite ready to run yet, however. The final step, linking. In the final step, a linker combines the machine code produced by the compiler with any additional code needed to yield a complete executable program. This additional code includes library functions, like printf, that are used in the program. Fortunately, this process is often automated, so you won't find it too hard. In fact, the preprocessor is usually integrated with the compiler, so you probably won't even notice it at work. The commands necessary to compile and link vary, depending on the compiler and operating system. Under MinGW and Windows, the C compiler is usually named GCC. In Linux, it'll be CC. To compile and link the hello.c program, we would enter gcc hello.c in the terminal. Linking is automatic when using GCC. No separate link command is necessary. After compiling and linking the program, GCC leaves the executable program in a file named a.out by default. GCC has many options, one of them the -o option, which allows us to choose the name of the file containing the executable program. For example, if we want the executable version of hello.c to be named hello, we would enter the following command: gcc -o hello.c. There it's done. And now to run your first program, all you need to do is type a full stop, a slash, and the name of your command, the name of your executable file, hello. And it outputs hello world and advances us to a new line. That's it. That's your first program written in C. You've taken your first step into this world. Welcome. So that's it for today's lecture. You've learned a lot today. Tomorrow we'll start with variables, arrays, and other things, and we'll soon make our own text editor. I hope you liked this video. If you have any questions, type them out in the comments. I'll try to answer each and every one of them. If you liked this video and thought it was helpful, like the video and subscribe to the channel. Thank you very much. See you later.